30 seconds and counting. 25 seconds and counting. We are still go. 20 seconds. Guidance alert. The guidance system now going internal. 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence start. 5, 4, 3, 2, 1.
Good evening to my viewers in Europe and Africa, and good afternoon to my viewers in the Western Hemisphere, most of the Western Hemisphere anyway. Good very early morning, or I think more kind of maybe a more mid-morning, I think, in a lot of the Pacific Rim in India. Welcome to the Angry Astronaut, and welcome to Starship Flight 8. So here we go again. And so quickly also, SpaceX once again demonstrates how rapidly they can turn things around, how rapidly they can effect the necessary modifications and changes to a rocket in the aftermath of a disaster, which definitely happened with Flight 7, the destruction of the upper stage of the Starship portion of the vehicle, and re-entry with a lot of debris getting scattered everywhere and numerous flights being redirected in the Caribbean region because of this. So all of that being the case, though, let's go ahead and see where everybody's checking in from. So feel free to let me know where you're watching from, and once again, here in the United Kingdom, it's already pretty late at night, and we are going to be pushing it really late indeed. Hello, John Morgan in Foremarks UK. Thank you so much for always being here. Hello, Indiana, and Robert. Thank you so much for that super chat, jumping in as you always do. One of my longest term supporters, my most loyal supporters, Robert De La Cruz. Thank you so much. North Central Texas. Hello, Romania. Let's go, Flight 8. Absolutely, that's what we want. Hello, Wales and Tucson. Really appreciate your support. And let's see who else is checking in today. We have over 90 people watching already. Thanks, appreciate it, because I jumped on a little earlier than I was anticipating, because it looks like SpaceX is going to be jumping on here pretty certain. Looks like we have Washington checking in. So Jamaica. Hello, Jamaica. Thank you very much for Long Island, Ethiopia, you said? Okay, we had in the short form. By the way, again, because of some changes, Missouri also in the short form. And I can't see that chat. I apologize. I have my producer telling me in my ear, we are including folks on the shorts, the vertical format as well as horizontal, for the second time, simultaneously trying to attract a wider variety of viewers. And we've been getting a lot of new folks who are new to spaceflight, who've only just recently started checking up on this stuff, answering a lot of questions like, what is Artemis? A lot of folks don't know. So once again, welcome to all the new viewers who are joining the Angry Astronaut. We're gonna hopefully show you folks how exciting spaceflight can be. Hello, Jamaica and Enfield and Hungary and Virginia. John, thank you so much for the tenor. Really appreciate it. Going to be another booster catch. I think it's very likely. SpaceX is demonstrating that they're really good at catching those boosters. And again, the question was asked of me, what is Artemis? And, because some folks don't know, we're going back to the moon. We're putting human beings back on the moon for the first time in over half a century, or at least that's the plan right now. And Starship is an important part, a critical part of that plan, because Starship is the HLS, the human landing system for astronauts landing on the moon. A old-fashioned, expendable, expensive rocket called the SLS will send the astronauts to lunar orbit, and there they will transfer over to the Starship human landing system, and Starship will take them down to the surface of the moon and then take them back up to the Orion capsule, which will be orbiting the moon, and then the Orion will bring them back. So it's very important that today's test go well, because this is the ship that's going to be putting people back on the moon. Thank you so much. Who's that one from? Produce Liam. Liam Lawless, $10 super chat on the vertical format. Thank you so much. Really appreciate your support. And once again, welcome. Glad to have you folks joining us today. Hello, Stalybridge, UK and South Australia. Really appreciate you joining us in South Africa. Thank you very much for joining us as well. Hello, Houston. Real question is how the heat tiles hold up. Yes, indeed. Very, very important. Can't catch it all day. Won't go anywhere if those don't work. It's important that we get 100% reusability on Starship, even though reusing the booster is a positive thing, and we still aren't at that point. Also, the boosters, they've been caught, but none of them have been reused yet. Got to have that happening as well. It's going to require reusability in order for Starship to be an effective system for putting people on the moon, or really to travel to any interplanetary destination. Leo, thank you so much for your generous support. Really appreciate it. Folks jumping on with super chats right off the bat, really appreciate it. It is those super chats that will allow me to travel to launch sites. For example, Shetland, where the first orbital launch from Western Europe will be taking place this year. Also, I'll be going to Australia. There's going to be a orbital launch attempt next month, or actually this month. We're talking a couple of weeks from now. Australia will be heading to orbit as well. Also looking forward to visiting Rocket Lab's facilities in New Zealand. It's, your super chats and your support and Patreon, and also the merchandise that you folks have been generously purchasing lately. All that really seriously contributes to my ability to do these things. By the way, all this new merchandise, the merchandise link is going to be pinned at the top of the chat later on today, and we have a contest going on. Whatever type of merchandise sells the most means that I'm going to dedicate a week to that topic. And right now, the alien UFO fans have jumped out into the lead at the moment. They have a narrow lead in terms of the number of shirts that they purchased. By the way, the merchandise selling better than merchandise has ever sold on this channel before. Thank you so much, all of you who have done that. But the UFO fans, once again, they've jumped out into the lead. And in second place is a space flight related week of content. And that's for the Angry Astronaut t-shirt with the Hohmann orbital equation. That was built into that. All of these designs customized for this channel and made by these incredible folks at Sunline. Sunline being my brand new company in Texas. They, by the way, make merchandise for SpaceX in Boca Chica. SpaceX sells their merchandise, official SpaceX merchandise. It's amazing. So once again, I'm doing business with the folks who also make shirts for SpaceX. So very cool indeed. What are they using for shielding? They have a variety of heat tiles, actually. And that's another important aspect of this test, is the fact that not all the heat tiles are the same. They're actually testing a variety of heat tiles on this flight to determine which one is going to be the most effective. Right now, the tiles have been largely effective during re-entry, but not 100% effective. And so they're still looking at different solutions for a heat shield, because there still have been. Pardon me? Go ahead. Okay, looks like We're checking to see if SpaceX is already live at the moment. All right. All right, we got a SpaceX splash screen at the moment. We'll go ahead and bring them live, and then when they come on for the first minute or so, we won't be bringing them on because they'll be copyrighted music. But after that, we'll be bringing you, of course, SpaceX coverage in Boca Chica once they become live. Hey, Angry Angler, I met you on the ferry on the. The Angry Angler. Hello, Angry Angler. I remember you so well. Boy, thanks for tuning in today, Angry Angler. This gentleman was a fisherman who was on the ferry to Shetland a couple of years ago during my first visit to Saxavord. We had an opportunity to talk during this experience. It was a great thing. So yeah, during that time, I gave this gentleman a little bit of information on the things that are happening with space flight in the United Kingdom. It was a great visit. So I'm thrilled, actually, that you joined the chat today. Thanks very much. I hope you enjoy this coverage. So, oh, shielding to protect them, says Pete Rowland. If we're talking radiation shielding, yes, that's a very, very good question, because right now we don't know what SpaceX's plans are in this regard. Are they just going to use the stainless steel of the vehicle to provide minimal protection from cosmic rays and solar radiation? Let's hope not. The best shield against radiation is water. If this, and that's an advantage that Starship has, because Starship can carry a very large payload, 100 metric tons. If they were to use the water that they have for just for everything that's commonly needed for water on a spacecraft, if they were to store that in tanks on the outside of the habitation area, that water would provide a tremendous amount of shielding against radiation. And also, contrary to popular belief, water that has been bombarded by radiation does not become contaminated or dangerous in any way. You can use that water for shielding purposes and then still use it again for drinking, whatever. I've actually seen a nuclear reactor that uses water for shielding the reactor core, and then that water, very warm, is vented straight out into the ocean. But it's not contaminated, it's not dangerous, it's very safe water, but very warm water. And so as a result, fish gather in large schools around the pipe that the water flows out of, because it's a lot warmer than the surrounding ocean. And then many seagulls and other seabirds gather around there as well, because there's so many fish. And of course, they enjoy snapping up all those fish, and it doesn't present an environmental threat to any of those people or to any of those creatures as a result. So yeah, water is the best possible shield against radiation. But unfortunately, we don't know what SpaceX's plans are. Plastic Pinocchio, thank you so much for the €6. Really appreciate your support. Appreciate everybody's support today. Once again, we have the SpaceX splash screen right now, but they are not yet live. All that is happening right now is a repeat of Flight 7. So Starship is going to be deploying some dummy satellites, assuming it actually manages to get to space, gets up to low Earth orbit. Even though it will not orbit the Earth, it will achieve an orbital velocity, just not the right trajectory to enter into orbit, because of course it re-enters the atmosphere about 45 minutes later once it travels halfway around the planet. So they're also going to relight at least one. Okay, go ahead. Liam Lawless, more support. Thank you so much for some popcorn, apparently. Thank you so much for your support. Deeply appreciate it. Mark Little, thank you for the £2. Really appreciate it. Go SpaceX, absolutely. And looks like they're firing up their intro right now. So we should be seeing some coverage from SpaceX here shortly. So once again, a critical flight for SpaceX today. It is important that they bounce back from that last setback, from the loss of the orbiter last time, all that debris coming down over the Caribbean. They need a win here. They need a success and a big jump forward, because if this flight is successful, then they're going to try to catch both the booster and the orbiter on the next flight and demonstrate 100% reusability, which is a jump they absolutely have to take. Are they live now? Three Chords, thank you so much for the $5 Canadian. Thank you so much, guys, for your generosity. Let's bring on SpaceX.
Minutes, 39 minutes away and counting down to a liftoff at 5:45 p.m. Central Time today.
Yeah, and if you were wondering, yes, that is the pad just behind us. Now, just over 1 month ago, we saw the second ever tower catch of the Super Heavy booster there at that pad, and
So
that was also the first ever flight of the
super
next
chat.
generation of ship, which successfully lit all 6 Raptor engines and flew for several minutes before contact was lost.
That's right. We completed our investigation following that mission, made a number of hardware operational changes for today's flight. We're going to detail all of those in just a few minutes. Important to remember, though, progress in a developmental program like this one, it's not always linear. There's no comparison, though, for putting that flight hardware in a flight environment to learn as fast as possible. And as always, primary payload for Starship Flight test campaign is data.
The objectives for today's flight will look very similar to Flight 7. We're planning to deploy simulated Starlink satellites and fly a range of experiments. We've moved a number of tiles from ship. We've removed a number of tiles from the ship for re-entry testing. We will also intentionally be stressing the flaps during re-entry so we can test the limits of ship before we get ready to attempt future ship catches. So lots of new testing happening today, and as always, excitement is definitely guaranteed.
And just checking on things at the pad real quick, as we're under 38 minutes away. We are tracking to 5:45 p.m. Central Time liftoff. We've got a window all the way to 6:30 p.m. We have started prop load. You'll start to see those frost lines building up on both Super Heavy and Starship. We're not tracking any technical issues, any range issues, any weather issues from a launch at that 5:45 p.m. mark. So we are loading prop on the vehicles, looking good for a launch in just a little over 37 minutes. Now, let's meet today's vehicle on the pad. It's the world's biggest rocket, Starship.
Yeah, you see it there on your screen, but to get an even better sense of how big Starship is, let's start with the average size human, which is about 2 meters high, or a little over 6 feet. Towering over our human is the length of the Millennium Falcon, which comes in at 35 meters. Our Falcon 9 rocket, which is has the payload fairing attached, is double the height of the Millennium Falcon at 70 meters. And twice nearly the size of that is the fully stacked Starship, just over 123 meters tall. The ship is about 52 meters tall, and the Super Heavy booster alone stands at about 71 meters. So it's pretty big. And we do have plans to make the ship and booster even taller in the future, if you can imagine.
And Starship itself features 2 major parts. We've got ship, that's the fully reusable upper stage powered by 6 Raptor engines. And then we have the Super Heavy booster that's fully reusable first stage with 33 of those Raptor engines powering it. Super Heavy, the most powerful rocket ever flown. It's designed to launch, return, refuel, launch again with 0 refurb. And to make all of that happen, we also have Stage 0. That's everything else you see around it that enables Starship to fly. The tower, the orbital launch mount, quick disconnects, prop farm, everything. Stage 0 is also just as critical to achieving that rapid reuse as Starship itself.
Back on the rocket, the ship features 6 Raptors, 3 of them for sea-level engines and 3 for vacuum engines. Raptor Vacuum, or RVAC, is a similar design to the Raptor engine, but features a larger exhaust section and a larger expansion nozzle to maximize the engine's efficiency in space. It's also designed for vertical takeoff and landing on any hard surface, useful for when you're taking off from a place like Mars that's still waiting for its first launch tower.
And that ship is outfitted with 4 flaps that are used to control the vehicle's attitude during subsonic flight and to enable a precision landing.
Dwarven,
the 2 upper ones are right here.
Really appreciate it.
And then to achieve full reusability, the ship has to survive entry not just once, but multiple times. Every single time we send it up and bring it back. It does that with its heat shield, which we iterate on every single flight as we're just building towards a heat shield that requires no refurbishment. The one today, it's still composed of those thousands of hexagonal ceramic tiles, and they're designed to insulate the vehicle during that atmospheric reentry where some of those temperatures spike up as high as about 2,600 degrees Fahrenheit. That's one of the real big things we're still working on. Rapidly reusable heat shield has never existed in history, so just continuously improving on it right now is just a key focus for all of these flight tests.
And then there in between the first and second stages is our hot stage. We saw that in action first starting on Flight 2. The hot staging maneuver is when the upper stage engines are ignited before the booster engines are completely cut off. With hot staging, the rocket never stops accelerating during separation. So it's actually more efficient than traditional stage separation, even though it sounds kind of crazy. You actually see it there on your screen now. That is one of the upgrades that we made on Flight 2, thanks to lessons that we learned on Flight 1. Several of the improvements and upgrades made for today's flight will unlock our ability to fly longer missions, something that we'll want to start doing, as we start doing orbital flights around Earth, and of course, eventually to Mars.
And Ship definitely had
Jack,
a lot of
so
lessons
much.
learned
Really
on Flight
appreciate
7,
your
but
support.
Super Heavy
Thank you,
Booster
Jack.
Super Heavy Booster put on one hell of a show for our second ever return to launch site and catch. Marked our first reflight of hardware, shout out Engine 314, and it brought us a lot closer to full reuse. For more on that, get ready, Internet. We're going to be joined now by our buddy Chris out in Hawthorne. How's it going, Chris?
And thank you, Dan, and I couldn't agree more. Raptor 134 definitely started us down that path toward rapid reusability for the Raptor engines, and who knows, maybe we'll see it again. Stay tuned. Welcome, everyone, to Hawthorne, California. As you can hear, excitement is building as we count down to Starship's 8th flight test. Behind me, you can see one of our mission control rooms where engineers here in Hawthorne are assisting our flight control teams in Starbase, keeping an eye on various systems like Starship's avionics and, of course, those powerful Raptor engines that have quite a workout ahead of them today. Now, the Raptor engines you'll see and definitely hear today were manufactured right here in Hawthorne, California. And the engines on today's flight are all Raptor 2 engines, which is the same design we've been using for Starship's flight tests to date. And that includes all of the engines that have powered the 2 Super Heavy boosters back to Starbase for catch and recovery by Mechazilla. But here at SpaceX, we like to continuously improve our designs by eliminating the parts we don't need. We call this applying the algorithm, and that helps us simplify designs and drives us toward rapid, reliable reuse. And that's just what we're doing with our Raptor engines, like you can see here on your screen. I love this family photo of the Raptors because it really shows you the unprecedented step forward in rocket design that Raptor 3 is. And you can really tell that we applied the algorithm here, questioning the requirements for the engine, finding the parts we didn't need, and then optimizing for manufacturability and reuse. Now, one of the cool things about Raptor 3 is that it eliminates the large and heavy engine heat shields, which means that when we move from the Raptor 2 to the Raptor 3 engines on Starship, each Raptor 3 engine is going to save us about 1.1 metric tons of mass, and that's a lot of mass when you multiply that by 39 or more engines. So Raptor 3 will help us increase Starship's efficiency and as well as the amount of mass that Starship is able to deliver to space. And I got to say, personally, it's really exciting to be looking at the engine that will make life multiplanetary, beginning with Mars. But before we get to Mars, we still have a lot of important and critical development work to do. And it's flight tests like today's that help us do just that. So as we get ready for Flight 8, let's take a look back at last month's Flight 7.
All right, so we currently have more copyrighted music. So in any event, Rodney, once again, thank you so much to everybody who's been supporting us on Super Chats here. A question was asked about, when are we going to be doing the orbital refueling? I do believe that that SpaceX, they've mentioned it a number of times, they intend to test it this year. Definitely, they need to carry out a full Starship to Starship refueling operation this year if they want to have the slightest chance of staying on target for getting to the moon, because it takes more than just one refueling. It takes as many as 10. That was according to SpaceX themselves the last time that they were asked point blank about that issue during a press conference call that I was on. And at the time, the Administrator Nelson at the time, point blank demanded an answer as to how many refuelings it was going to take for Starship to be capable of flying to the moon or to Mars for that matter. The answer came back as 10. So we need to have a fully successful test of the Starship to Starship refueling process this year. Absolutely, in order to have the slightest chance of doing 10 of those things back to back in rapid succession in the near future. So yeah, quite a challenge coming up, and quite a number of tall orders in front of SpaceX and Starship in the near future. And again, this is why this test has to go off well, and this is why the next test needs to happen as rapidly as possible. Lot of challenging things in front of SpaceX, and again, another thing to remember, the ship-to-ship refueling has never really been done except on the most basic of levels with tiny satellites transferring, a few gallons of fuel, a few liters of fuel. I mean, we're talking transferring 100 tons of fuel at a time in microgravity. That's going to be a very challenging thing indeed. So yeah, it's Starship needs to get on board with these things soon if it's going to be an operational interplanetary transport system. 10 is unreasonable, says Respond. It's true, but unfortunately, that's what it's going to take, because Starship can only carry so much fuel, and you have to completely refuel it. All right, yep, we're going to go ahead and bring SpaceX back now.
Again, I know seeing my first booster catch, I'll never forget.
There's nothing like it. Yeah. Nothing on the planet.
Now, using the data from Flight 7, we've made some key improvements under the hood for today. Flight 7 taught us a couple of important things that changed some of our pre-flight testing to help us investigate more. First, we saw a harmonic response several times stronger in flight than we saw in testing.
And harmonic response, in this case, it's essentially vibrations that we're seeing go through the structure. Rocket engines, as you can imagine, create an incredible amount of noise and vibration, which then passes through every component of that rocket. And on Flight 7, we saw those vibrations happening at a very specific frequency, and they were placing some extra stress on that hardware in Starship's propulsion system. This is most likely what led to propellant leaks that we saw that eventually cascaded into fires and ultimately ended with loss of contact with the ship.
As part of our investigation, our team at Starbase took this flight's ship through a 60-second static fire on the Starship test stand, which is 10 times longer than any previous static fire. During this test, we cycled through multiple throttle levels. In fact, you can see that on your screen now. We cycled through multiple throttle levels on the engines to recreate different conditions seen within the propulsion system during flight. And we tested some hardware changes on fuel feed lines to the Raptor vacuum engines.
This gave us just the extra data that we needed to eventually implement new hardware that's installed in those fuel feed lines for the RVAC, the Raptor vacuum engines. Also tweaked a couple of other things like the temperature of the propellant as we're feeding it to the engines. Also the throttle level that we set for those engines during ascent. Having the ability to do a 60-second static fire, just one of the ways we're trying to expand our test capabilities here at Starbase. You want to test like you fly as much as possible. That just helps us to iterate even faster.
Yeah, exactly. The fuel feed lines to the Raptor vacuum engines, which are unique to this upgraded version of ship, look like large straws running through the oxygen tank. Today's vehicle has one of the hardware configurations we tested in that extended static fire because it showed it was able to minimize the harmonic response and lower its amplitude or strength.
We also took another look at where those fires broke out, specifically in what we call the attic. That's an unpressurized space between just the bottom of the ship's liquid oxygen tank and the top of those engine heat shields. Fires in that space resulted in a loss of vehicle back on Flight 2 and also on Flight 7. So we took some steps to make it more resilient to leaks in the future. To do that, we added a pretty hefty purge system. It's going to use gaseous nitrogen. It's pretty similar to the CO2, the carbon dioxide system we use on booster. It essentially just floods the zone with an inert gas to prevent a fire from ever starting. And then in addition to this, we increased the attic's natural fire defense just by adding some additional vent holes. That helps to keep the attic pressure as close to just vacuum as humanly possible as Starship flies into space.
And for the next generation of ship, we're running the algorithm. We're going to try and do the next best possible thing and delete some of the unnecessary space. So that ship will be using Raptor 3 engines, which will let us reduce the attic volume and eliminate the majority of joints that can leak into the space. In the end, what you're seeing take place with these changes is the core of our test program. We fly hardware all together in a real-world environment. We learn from the data, we make upgrades, and then we fly again. Ultimately, we fly to learn, and we're learning a lot.
That's right. Now, for today's flight test, we're going to be attempting to do everything we didn't get to do on Flight 7. We're still looking to get our first re-entry with this upgraded version of ship. Also intentionally trying to stress it to gather real-world data on just where the vehicle's boundaries are. So don't be surprised if it's not a smooth flight down to a landing for ship today. As always, it's going to start with liftoff. The 33 Raptor engines on super heavy igniting, lifting both it and Starship into its ascent, and it's going to power us all the way until hot staging.
Yeah, those engines on the ship will ignite while the ship is still attached to the booster. This will create that stage separation that we see there. Second stage will continue to go on its way. The booster will make a flip and come back here to the launch tower just behind Dan and I for hopefully what we will see the third ever booster catch.
Meanwhile, ship continues its ascent, gets into its suborbital place in space. We're going to have a test satellite deploy, pew-pew, Starlink's firing out. And then we're also going to do a Raptor relight, relighting one of those sea-level engines before we get to ship re-entry.
Troubleshoot by the state machine.
And the ship will continue through, make its entry phase that lasts for a few minutes.
And if some comms did just go out, we heard that an operator hold got in, so they are troubleshooting one issue. As we continue to move through prop load, we'll get some more details on what caused the hold, and if we start to reset to a new T0. We are still loading prop on the vehicle, so essentially putting that hold in means that if we get through everything and we hit that T-minus 40-second mark, we'll hold there and wait to clear the issue if we haven't cleared it at some point in the next 20 minutes.
Yeah, for those that are unfamiliar, that T-minus 40-second period is an opportunity to troubleshoot, unlike our Falcon timeline. So we do have a little bit of leeway.
Yeah.
Continuing on with today's plan, that ship will be making a soft splashdown in the Indian Ocean, as we have seen before. We are launching at 5:45 p.m. Today. This evening launch will allow us to have daytime views of the ship as it makes its splashdown. So,
yeah,
good news.
It's a lot on ship's plate, but we're still hyper-focused on finding all of those real-world limits of Starship. We want to be able to prepare to return ship to launch site and catch it. A lot of these recent upgrades are just made to enable that to actually happen.
Flight 7 premiered a huge block of upgrades to the upper stage to add more capability to Starship. And with Flight 8 today, we're hoping to get through a full flight. Starting us off, the forward flaps got a redesign. They shrunk in size and shifted toward the top of the vehicle and away from the heat shield. And that will significantly reduce their exposure to re-entry heating. Also, by making Starship 2 meters taller, we added about 25% more propellant volume, along with propulsion upgrades such as vacuum jacketing of the feed lines, new fuel feed line system for Raptor vacuum engines, and an improved propulsion avionics module.
Yeah, ship got a little bit taller. That extra prop's going to allow us to fly those longer missions. We're not planning on stretching it a whole lot more beyond this in future ones, but then, you know, once we're flying the next version a lot, it'll be going. Just like the previous flight, a lot of tiles have been purposely removed. is, again, we're trying to stress test all of the vulnerable areas, call this the missing tile test. Those tiles are removed in strategic locations all across the vehicle, including critical areas like those tanks and over the flap seals, as we use this flight to just really push those boundaries. In addition to that, we have some metallic tiles, again, that are being tested, including one on the right of this animation that has some active cooling built in.
The vehicle's avionics also underwent a complete redesign with things like 4 upgraded Starlink terminals, combining Starlink, global navigation, and RF communications. You can see that location there on your screen. And on the sides of the vehicle, non-structural versions of the ship's catch fittings are installed to test the thermal performance, along with a smoothed and tapered edge on one section of the tile line to address hotspots that we observed during Flight 6.
And once more, we're back at testing some radar sensors on those tower catch arms. We did that last flight. We're doing it again as we look for some additional ways to measure the distance between the arms and the vehicle. Catching the ship's going to be pretty different from catching the booster. It does that flip right before, so your antennas are going to rapidly reorient. And so just having any extra sensors on the ground side, you're adding extra layers of control while the ship and tower talk to each other for a catch.
In another first, Starship will deploy 4 Starlink simulators. They are similar in size to our next-generation Starlink satellites. With unparalleled payload capacity and full reusability, Starship will be able to deploy our more advanced V3 Starlink satellites, which will revolutionize global connectivity with Starlink all over again.
Each one of those Starlink V3 launches on a Starship is going to add about 60 terabits of capacity to the Starlink network. To give you some context, that's about 20 times the capacity of what we're adding with every V2 mini launch on a Falcon 9 right now. That's going to help us expand Starlink's network, expand its impact in the coming years as we expand that access to high-speed internet all around the world and eventually beyond. And the Starlink simulators that we're deploying today, they're going to be on the same suborbital trajectory as Starship. We expect them to demise as they enter in the atmosphere. And then Starship's trajectory itself looks very similar to our last several flights, splashdowns targeted in the Indian Ocean. And on top of all of that, we're also going to relight a single Raptor engine again while in space. We're just trying to get data on in-space Raptor burns. You're going to need those for deorbit burns when we're doing orbital missions, and eventually when we're doing missions way beyond Earth and we're on our way to Mars.
Yeah, so just like you said earlier, Dan, there's a lot on Starship's plate for today. But one of the hallmarks of these Starship flights are the incredible views that we get throughout the flight, courtesy of Starlink. Every day, we're working to expand the Starlink network both on Earth and in space. For how all this connects us to the big mission, let's head back to Chris.
Thanks, Kate. And as fans of Starship may know that Starlink enables us to bring you a lot of those unprecedented views, both from space and on Earth. Personally, I love all those epic views of the plasma wrapping around Starship during re-entry. So thank you to our Starlink teams who enable all of those amazing views and the information we get. Now, in addition to the dozens of cameras on Starship itself, as you see on your screen here, we also have mobile Starlink camera kits deployed in the middle of the Indian Ocean, as you're seeing from a previous flight. Starlink also allows us to connect our aerial cinematography units on the ground at Starbase and at other strategic camera spots around Texas and the world. And that's all part of how it comes together to help us tell the incredible story of Starship, both on and off the planet. So thanks to Starlink, Starship is now capable of streaming more than 120 megabits per second of real-time, high-definition video and telemetry through every phase of flight. This not only provides those incredible views of reentry for all of us, but also the invaluable engineering data to help our engineers rapidly iterate across all systems of Starship. And all of that streaming data today will be put to good use with the more than 30 cameras that are on the vehicle for today's flight. Now, Starlink is the world's largest satellite constellation operating in low Earth orbit to deliver high-speed, low-latency broadband internet. This provides internet access to people around the world, many of whom have never had connectivity before. As of today, Starlink is serving more than 125 countries, territories, and other markets, and has more than 5 million active customers and counting. But to meet the growing global demand for high-speed internet, SpaceX recently expanded its factory at Bastrop, Texas, and introduced Starlink Mini as well as an upgraded version of the Starlink standard kit. Here's our first ever look inside our brand new Bastrop facility.
copyrighted music at this point. So real quick, just want to address some of the things. A point was brought up recently that the military has mastered mid-air refueling. I assume is what we're talking about there. The mid-air refueling of bombers, fighters, etc. That's been done for a long time, actually, well before the time that I was born. The thing that is different, the thing that is unique about orbital refueling is the fact that it's being done in microgravity. That makes it so much more difficult because fluids do not behave the same in microgravity as they do under full gravity. Bubbles don't float to the surface in the same way. Obviously, bubbles instead remain suspended throughout all of the solution, and bubbles can clog up a fuel line. It can inhibit a refueling process. It becomes much more difficult to transfer liquid from one container to another in microgravity. It's been experimented with a number of times on the International Space Station with small amounts. We're talking like a jerry can worth of water being transferred from one container to another. And even then, it was challenging. And so now with 100 tons of this stuff, it makes it even more difficult. So I'm not saying it's impossible. It certainly can be done, but still, it's a challenge. Right. Tori Bruno, who is, if those of you are not familiar, is the CEO of United Launch Alliance. He's actually a rocket scientist, and he put out a couple of articles about the challenge of orbital refueling, the various technical challenges involved. According to him, it's going to be an extreme level of difficulty. Same time, though, Tori had said things about SpaceX's reusability and such that he predicted wouldn't even be possible, but they pulled it off anyway. And I'm pretty sure that they'll be able to pull this off as well, but it could be very difficult to do, especially if we're talking about 10 refueling missions back to back as quickly as possible. Why does Blue Coast look like an upside down dumpster? Well, you know what? I like how it's built because it's squat and has a low center of gravity, which I think is absolutely crucial for successfully landing on lunar regolith. Let's go ahead and bring SpaceX back.
Reusable and hardy enough to withstand hundreds of launches at a time. Now, over at the production site down the road, we're also building a new integration and refurbishment facility called Gigabay. And Gigabay, as the name implies, will allow us to process more Starships at the same time over our current megabays. But Gigabay isn't just for Texas. If that weren't exciting enough, we're also further expanding Starship operations into Florida, bringing production and launch capabilities to the Space Coast. As Starship flight testing, development, and launch cadence continues to pick up pace at Starbase in Texas, over in Florida, we're building a Gigabay as well. Gigabay will stand 380 feet tall and will provide about 46.5 million cubic feet of interior processing space and about 815,000 square feet of workspace. Now, as environmental impact statements continue for potential Starship launches and flights from both Launch Complex 39A at Kennedy Space Center and Launch Complex 37 at Cape Canaveral Space Force Station, we plan to complete the Starship launch pad at Pad 39A this year. And pending the completion of environmental reviews, SpaceX intends to conduct the first Starship launch from Florida from Launch Pad 39A later this year. Now, we're also interested in enabling Starship launches from Slick 37. And as part of this process, SpaceX has been given a limited right of entry for Pad 37 to conduct further due diligence at the site in order to move forward with the environmental impact study that's being led by the Department of the Air Force. Ultimately, we will have production, integration, refurbishment, and launch facilities in both Florida and Texas, driving the needed flight rate for Starship to help make humanity a multiplanetary civilization. And Kate, I could talk about this stuff for literally hours on end, but we've got a Starship to launch today. So how are things looking 11 minutes before launch here?
Yeah, it's pretty cool that we're getting close to go time. Quick update on range and weather. For the range, the area around the pad has been well cleared. This includes the land, air, and sea space. So all is clear on the range front. That also applies to over in the Indian Ocean. The sea and airspace has been cleared as well for ships re-entry. Once again, we are making a soft splashdown in the Indian Ocean. So just the buoy cams are out there, and we'll get some great videos once again. Weather, we have a 35% chance of violating the weather the weather constraints for launch today. So it's not perfect, but it's not bad. Visibility also not so awesome. We can see the tower here. We're 2 miles away from the launch pad, but visibility around the greater area might be a little challenging.
Yeah, in terms of the vehicle itself, so right now you can see we're almost done loading prop on ship, almost done on booster. If you tuned in and heard earlier, we did hear talk about a flight controller hold going in. So just a reminder, all that means is we wouldn't be able to pass that T-minus 40-second mark. They're literally talking about it right now on the loops that they think they've got the problem figured out. It was an issue on the booster where we think we will be clear by about the T-minus 2-minute mark, and we will be able to move right through that T-minus 40, hopefully. So, prop load continuing. We're not holding or anything yet, and we're expecting that issue to clear before we get to that T-minus 40 mark. This morning, though, we did all of the usual checkouts, aligned the navigation systems, did all of our booster and ship tank purges, got them ready for prop load, chilled down the pad, which you can see all the cryo right now.
Chilling.
Things are pretty chilly out there. Prop load's been going. We just did a flap check out. We also do a wiggle check out on the chopstick arms as well. We are going to continue loading prop for about another 6 minutes. We're going to close ship at about 3 minutes, 20 seconds before launch. Booster just about 30 seconds later. So we've had at least one issue that we're still working in the background, expecting that to clear before we hit that kind of that hold gate at T-minus 40 seconds, and looking good.
Yeah. So bottom line, things are looking good for liftoff here in just under 9 minutes. We're now at, looks like 8 minutes and 49 seconds. So everything's looking green so far.
Yeah. Before we get any closer to liftoff, I need to shamelessly plug Starbase. I'm one of just a couple thousand people who work here. Soon to be the newest city in Texas at Starbase, and we're the largest employer in the area. We're always hiring, so visit spacex.com/careers, see all the openings. It's where the future is being built, and it's a future we can all be pretty excited about. So yeah, come work here. Anyway, back to our regularly scheduled program. Let's launch a rocket.
All right, so we're coming up to 8 minutes until liftoff. As we mentioned before, flight controllers are already on console. They're located in our Ad Astra Launch Control Center, about 6 miles away from the pad. But they will soon be moving here with us to Star Factory. So a lot of excitement around that, certainly growing.
Yeah, and again, general status check. We're continuing to progress. We're under 8 minutes away. We're tracking an issue with booster. We're expecting that to clear. Still looking good for launch. Speaking of booster, let's talk about catching one.
Absolutely.
The tower's 2 giant robotic arms that lift and stack Starship on a Super Heavy for final integration ahead of flight. We also use those to catch. It means we don't have any landing legs in the booster. Makes the booster lighter. Means we can throw more payload into space.
Exactly. Following liftoff and after the 2 stages separate in flight, Super Heavy will return to the launch site, the same exact launch site that it lifted off from, reignite its engines to slow the vehicle down. Here we see playback from a previous booster catch. I believe that was our first booster catch. The vehicle will slow down, tower arms will come out and catch the booster.
And just like the last few times, literally thousands of different vehicle pad criteria have to be met before we bring a booster back and try to catch it. We need healthy systems on Super Heavy, on the launch tower, and we need that final manual command from the mission's flight director for the day. If that command isn't sent before we finish the boost back burn, or if any of those automated health checks kick us out, the booster defaults to a trajectory, takes it to a landing burn and a soft splashdown in the Gulf.
Yeah, we have said it multiple times before, but it still holds true today. We accept no compromises when it comes to ensuring the safety of the public and our team, and the return will only take place if the conditions are right, and there are many of them. So there's a chance that we may not get to catch the booster today.
Yeah, and one aspect of the return and the catch of that booster is the audible sonic boom in the area around the return location that happens as the booster's slowing down from supersonic speeds. It's similar to sonic booms that were heard during the return and landing of NASA's space shuttle for anyone that was in Florida for those.
Sonic booms like these are unique to vehicles returning from space and are one of the hallmarks of reusable systems like our Falcon 9 and Falcon Heavy vehicles. The general impact to those in the surrounding area of a sonic boom is basically a brief thunder-like noise. And I've heard sonic booms before, but I got to experience my first in-person Starship sonic boom on Flight 7, and I can confirm it's pretty fun to experience.
Okay, so never mind. Thought we had copyright music. We don't.
And as someone who has heard sonic booms many times in Florida, they are definitely a hallmark, and what a way to announce a returning space vehicle's return for reuse. Now, here in California, as you can imagine, the excitement is growing here. The crowd is growing. Kate mentioned our flight controllers in Ad Astra in Texas. Here in Hawthorne, we also have controllers on console in Mission Control, helping those teams in Texas monitor Starship's various systems, including the avionics and those 39 Raptor engines that were built right here in Hawthorne. Now, with 4 minutes, 30 seconds to go, Dan and Kate, how are we looking for a launch today?
So we are still looking good. We're just about fully topped out on propellant on both vehicles. The closeout's going to be coming up in about a minute on ship, and then about 30 seconds later on the booster. We are still hearing chatter in the background about the booster issue that we're tracking. We may still be able to pass the hold, but if we need to hold at T-minus 40 seconds, we have several minutes that we can hang out there and work to just kind of troubleshoot those final issues before we get the go. Once we're fully loaded on prop, which is coming up soon, we've got just shy of 11 million pounds of liquid oxygen, liquid methane on both of those stages. And then once we're done, we're going to see that we're going to hear the ground lines do what's called pushback. So all of that propellant gets pushed out of those lines back to the tanks, clearing the pad for launch.
Now, in the next few minutes, the guidance system will perform a final alignment. The automated flight safety system will be armed, and thrust vector control, or TVC, checkouts will be performed. As we said, if we do need to hold, it would come at that T-minus 40-second mark. That is the point in the countdown where we can pause to wait for final checkouts or pressurization, or if we need to continue to work through that issue. So once we pass through that T-minus 40-second mark, a number of things are going to happen quite quickly. The ground spin and ignition systems come up to flight pressure. The ship's going to go on to internal power. And after that, the quick disconnect, or QD, arm lockout is removed in preparation for retraction shortly after T0. And once we do pass that T-minus 40 seconds, we still have the ability to recycle the count under certain conditions back to that T-minus 40 seconds and hold there to assess what happened, and if we can proceed again to T0. But that's only in certain situations.
All right, so we're just about 2.5 minutes away. We do have a couple of things, like if we hit T-minus 10 seconds and you see water start flowing out of the deflector, that is a reason for us to scrub for the day, is that's once it's turned on, it doesn't turn off. And then we'll have to refill the tanks on both the water farm and the prop farm. Our team's gotten really, really good at refilling stuff really quick, so we can reposition for about a 24-hour recycle if we need to.
Yeah.
But
speaking of
we're coming up. We're coming up just under 2 minutes away. Now hearing we might hold at that T-minus 40-second mark while they still talk through a couple of troubleshooting steps. But again, if we hold there, we can hold there for several minutes, even with all prop fully loaded on the vehicle before we can release the hold and decide to move forward. All right, less than a minute and a half away. Again, keep your eye on the clock. Look for T-minus 40. We may hold there. It's not a rocket launch unless you're talking nonstop in the background until right before you lift off.
Once again, if we hold at T-minus 40 seconds, we have an opportunity to hold there for several minutes. This is unique to Starship. We don't have this ability on Falcon.
As we're about 15 seconds away, we did just here. We are going to hold at T-minus 40. So look for the clock to pause when we hit T-minus 40 as they finish troubleshooting. And then we'll let you know as soon as we start hearing more, and if when that clock's gonna start rolling. So holding at T-minus 40.
Thank you, Matthew. Thank you.
The team's talking in the background,
really
still troubleshooting, and we can hang out here for a couple of minutes.
Okay, so we're in a 40-second hold now, guys. They're gonna troubleshoot a number of things. Probably will sit there for a few minutes.
All right, and it sounds like we cleared the issue on the booster. We're now holding for a late braking issue with ship, so they're talking through that right now.
Dan, you mentioned things that we've gotten really good at. It's incredible to think that we just stacked this vehicle earlier this morning, and we're already, through prop load. Prop load's pretty much complete and ready to go. It's a very slimmed down timeline.
Yeah, this by far will be our fastest. We stacked the thing for the first time ever with these vehicles less than 24 hours ago. We really want to get to a point where we can, fly rapidly, fly as quickly as possible. And so this is definitely a case to try and push that forward. No wet dress or anything like that with these vehicles.
Absolutely. And should this booster come back for a successful landing, you were talking about the rapid part of rapid reusability. This booster may fly on a future Starship flight if we're able to catch it and bring it back online. So for those of you that have just recently joined us, we have paused at T-minus 40 seconds just to assess and work through a problem that popped up in the countdown, and we are holding here as the teams troubleshoot it. We believe that we have put in a solution and we will be able to proceed, but we have some chatter on some nets indicating that we're just holding here for a few more seconds. Now, this is a great opportunity for the teams. This is unique on Starship. We don't have this ability on Falcon to hold here, partially because there's just so much propellant that it takes longer as a whole for it to cool down with that amount of volume that we have compared to the Falcon vehicle. But this T-minus 40-second hold is pretty cool because basically everything that would have been a scrub is actually just an opportunity to hold here and work through it. Or I should say many things, not everything. Like I said, we're working through an issue now, but we can also pause here for final checkouts or completion of pressurization to get up to flight levels, that kind of thing. So it's a nice feature to allow the team to wait for final checkouts or assess final prop levels or engine health and that kind of stuff.
So just stack this, no wet dress rehearsal at all. Interesting. Like I say, more things could go wrong. There could be more reasons for a scrub under those circumstances. If these two components have never been tested together before, they've never had a wet dress rehearsal on this rocket before. So things could come up more frequently than under normal circumstances in a situation like this. But again, as they explained, they want to get to the point, SpaceX does anyway, to be able to just toss these things on the launch pad and let them go. Of course, that also increases the chance of an anomaly, of a problem on the pad. But at the same time, those are the risks that SpaceX is willing to take in order to achieve rapid reusability, very rapid reusability, which once again is absolutely essential if they want to, for example, do 10 low Earth orbit refuelings very quickly. Reason it has to be done quickly is because of something called propellant boil off in microgravity, and especially in space, where you have vehicles being subjected to extreme cold followed by extreme heat when the sun shines on them. Propellant boils off into space, and regardless of how much insulation you have on it. And under those circumstances, you need to get that refueling taken care of quickly. Otherwise, you're going to lose a lot of your propellant during the refueling process.
All right, and if you're just tuning in, we are still holding at this T-minus 40-second gate. We cleared an issue on the booster that we were working up until the hold, still working one on ship, and team still continuing to discuss in the background. We can still hold here for several more minutes. If we're not able to resolve the issue or find a workaround, then we would have to essentially scrub and stand down for the day. If that does happen, we can go as early as tomorrow, but that clearly depends on what work we might need to do to fix any issues. So just obviously stay tuned. But right now, we're a little over 5 minutes into this hold today. We've got a couple more minutes that we can hold at T-minus 40 before we have to kick out. Essentially, looking at a lot of those propellant temperatures on both vehicles, you want those to stay in pretty specific ranges for engine startup and things like that. That's what generally drives how long we can hold at T-minus 40. So still hanging out. As soon as we hear an update
this is not
on
in
the
Florida.
ship,
This is in Boca Chica,
we will
Texas.
let you know.
Very, very far south Texas, right at the Texas-Mexico border on the Rio Grande, actually. The southernmost point in the continental United States. Again, trying to get as close to the equator as possible in order to... Okay,
it's starting to sound like we might have a decision real soon. All right, you see the clock rolling. It is time to go for launch.
Here we go. They're counting down.
30 seconds to go.
Oh.
And we just heard a hold. So we kicked. Psych. No. So we did kick out back to the T-minus 40 hold.
Doggone it. Ugh. So it seems like a majority of folks think we're going to have a scrub here. We'll see. It wouldn't be all that surprising, given the fact that they haven't done a wet dress rehearsal or anything.
All right, so as we started counting back down, we did trip a few more holds automatically from the booster itself.
Yeah.
So we are now going to hang out here again at T-minus 40. They've got a couple more troubleshooting steps that they can take. If we're able to get through that, we can start counting down again. If not, we could always offload and try again on either tomorrow or another day. But right now, we're not done for the day yet. Still holding at T-minus 40 seconds. And as soon as we hear some more or start seeing that clock move, you will know if we're going to go for our launch attempt today or if we just try it again another day. So keep listening in, and we'll have an update shortly.
€6. Thank you so much for your generosity. So yeah, very seldom do we have Starship scrubs, to be clear. That has not come up much. But then again, to do things as quickly as they've been doing them, stacking these things for the first time yesterday, no wet dress rehearsal, all of that, I would say that could create a situation where scrubs might be a little bit more common. But then again, if we're talking about a company that can fight through these things and get rockets off the pad, man, these guys are good at it. Really, when it comes down to it, there's nobody better at this than SpaceX if you're talking about
All right, and we did just hear the call. We are going to offload for today,
and
so we
here
had
we
a couple
are.
of holds
We're
tripped
scrubbed.
as we started
We
counting
are
down from
scrubbed,
T-minus 40
guys.
again.
Sorry
And it's
about
not something
that.
we can
That
change
is a
with
big
small
letdown, but
config
once
tweaks,
again,
so we are going
as
to
I mentioned,
offload
we can go
our
ahead and
prop
cut the
and
feed
then
from
try
them.
again another day.
That's okay, producer. Folks, just there's nothing else that we're going to hear from SpaceX at this point, aside from the fact that they may give it another shot tomorrow, or perhaps not. Again, Jim, thank you so much. Really, really appreciate it. But again, to be clear, as I mentioned a number of times here, they are moving so quickly these days with no wet dress rehearsal, with stacking as quickly as they did. All of these things create an environment where a scrub is more likely, where they may not have that there are technical issues that they may not have spotted because they didn't have a chance to do a rehearsal prior to the launch. So, but again, SpaceX is good at catching these things, and I'm very confident that they'll be, if they don't launch tomorrow, they'll launch in 48 hours. I'm sorry, producer, go ahead. What happened on the vertical? Brian Spence, $50. My God, from the vertical side, from the I'll tell you, you guys are amazing. I am so grateful to you folks on the vertical, on the YouTube short side, who've decided to join us here when we decided to expand live streams over to you folks. Really appreciate everybody joining us here. If you get a chance, please check out the merchandise link at the top of the chat. As I said before, we have a contest going on where we're going to be giving away merchandise this month. And in addition to that, we also are competing as to what sort of week we're going to have. Will we have an alien/UFO week? Are we going to have a space flight week or a space science week? It all depends on what type of merchandise sells the most. But I'll tell you, it's been selling much better than I anticipated. As a matter of fact, these items are going like hotcakes. So thank you so much. Really appreciate everybody tuning in. Please don't forget to like and subscribe. And as always, stay angry about space.